So previous methods like solving trig equations graphically give us approximate or decimal answers, but we can find exact answers using algebra and also using the exact triangles and the unit circle. Okay, so first, if we consider the the exact ratios, triangles. So here's a triangle. Okay, so we have the smallest angle is pi on 6, or in other words, 30 degrees. The larger angle is pi on 3, or in other words, 60 degrees. Now, remember, the smallest angle, which is pi on 6, goes across from the smallest side, which is 1. That means the other vertical side is root 3, and the hypotenuse is 2. As far as the other exact value triangle, okay, that's the one with pi on 4. Now, I usually just draw it there, but you can do pi on 4 in both places. Or in other words, 45 degrees. And remember, this is isosceles, so that's 1 and 1, and then the hypotenuse is root 2. We're also going to need the unit circle that we should draw for each question. Okay, so for the first question, it says sine x equals 1 from x is between 0 and 3 pi. Okay, so first of all, for sine x to be equal to 1, if you consider, say, the graph of sine x, the first time it hits a maximum of 1 is when the angle is pi on 2. So that means x, or the smallest version of x, is pi on 2. Another way to think of it is on the unit circle, when is the y value equal to 1? That's up here at 0, 1. And remember, sine of theta is the y value. And so for that angle there, that is pi on 2, so it makes sense. That's another way to think of it. Now, here's that unit circle. I got A, S, T, C. However, because our angle is pi on 2, which is on the y-axis, we don't really need to worry about the ASTC in this case. So, because we're not inside a quadrant, we're on an axis. Okay, so now we're not finished because x doesn't just equal pi on 2, because we have to consider that x is between 0 and 3 pi. Now remember, this is 0, this is pi. If we go all the way around, we get back to 2 pi here. So we need to go all the way around plus a bit more, so let's think about that. So by starting at 0, we go around and we hit our angle for the first time here. That corresponds to just pi on 2. We've just moved around pi on 2. Now we're going to go around again. We're still not hitting our angle. Okay, we've gone around 2 pi, but we need to go around another pi. So another pi is like going around to pi here and stopping there. Okay? Now when we went around that second time, we hit our angle here. Again. Now, what is that angle that we're hitting? We've gone all the way around 2 pi plus another pi on 2. So we can find it by thinking of it as 2 pi plus an extra pi on 2. Or if you want, you can think about it as 3 pi minus pi on 2, because you could go all the way to 3 pi and then back pi on 2, so it's minus pi on 2. Either way, you're going to get the same value as 2 pi plus pi on 2. So our final answers are pi on 2. And what's 2 pi plus pi on 2? 2 times 2 is 4, so it's 4 pi on 2 plus pi on 2, which is 5 pi on 2. And then we're done. Okay, so the next one, it says cos x equals a half for 0 to 2 pi. This one's a little easier because we're just going from 0 to 2 pi, so we're only going around the unit circle once. And now we want to think about, well, cos x is a half. Which of these exact value triangles are going to help us for a half? Well, so a half is made of 1 over 2. So there's 1, there's 2. So we must be using this triangle. And if we remember, cos is adjacent over hypotenuse. So obviously 2 is the hypotenuse, so that's fine. But which angle has 1 as the adjacent side? That would be pi on 3. So our acute version of x is pi on 3. So let's just write that down. Maybe we can write acute x is pi on 3. Now let's draw the unit circle to consider whether or not we actually want pi on 3. So here it is. A, S, T, C. Now, first of all, looking at the original equation, we see that cos x is positive. So in which quadrants is cos x positive? It's the A quadrant and the C quadrant. Okay, now remember, draw in your little pi on 3 acute angle here. That helps you calculate it for angles of any magnitude because it really does help. Okay, so we know where our angles are. This first angle here is just pi on 3, so yes, we want to keep this pi on 3 that we've written down. Now we're going to go around 2 pi. I hit the next angle, but I don't really know what that is, so I go the full 2 pi, but then go backwards pi on 3. So what's happening is I moved to 2 pi, but then I subtracted pi on 3 by moving back. So my other angle is 2 pi minus pi on 3. So my final answers are pi on 3 for x, I should say, and 2 pi minus pi on 3, which is 6 pi on 3 minus pi on 3, which is 5 pi on 3. Okay, and then we're done. Now we keep going. Okay, we're solving both of these next equations for 2 pi. Sine of 4x equals root 3 on 2. Okay, so first of all, you might notice, we've got 4x and 2x. How are we going to deal with that? Well, one thing at a time. Basically, first looking at this equation in A, I noticed that sine of the angle is positive. So I'm going to be in the positive quadrants. So let's have a look where they are. And I do recommend drawing a unit circle, even if it's messy, for every single individual question. Okay, and where is sine positive? In A and S. And what angle do I want? What acute angle do I want? Well, the one with root 3 and 2 is this. And they're my angles, pi on 6, pi on 3. So sine is opposite, so opposite root 3 is pi on 3. So therefore, the acute version of 4x, the angle 4x, is pi on 3. Okay, now it's time to consider, now that we've done the triangle and the unit circle, which is a great start, now let's consider this 4x. What does that mean? If x is between 0 and 2 pi, the question is, what would 4x be between? Well, to get from x to 4x, I need to times that by 4. So I need to times everything in that inequality by 4. So I get 0 there and 8 pi here. Okay. So what does that mean? That means I need to go around the unit circle 4 times to get all my answers, because 2 pi fits into 8 pi 4 times. So we need to go around until we get to 8 pi to get all my answers. So we've got our first one, 4x equals pi on 3, and that's from going from 0 to that. It's pi on 3, and remember this here is pi on 3 as well. Okay, so now let's keep going. Okay, I don't know what this angle is, so I keep going to pi and then go back pi on 3. So my next answer is pi minus pi on 3. But I'm still not done because I need to finish going around And now I've only gone around 2 pi. So now I'm going to go around again. So I've just gone around 2 pi, and then I go plus another pi on 3. So that becomes 2 pi, plus pi on 3. And then I keep going, and I'll go to 3 pi, hit the x-axis here, go through 3 pi, and then minus pi on 3 again to go back to that blue line. So 3 pi minus pi on 3. Another way to think of it, if this is starting to confuse you, you could just think of adding 2 pi to these two, because we're going around an extra circle. So just get these two and add them to 2 pi. Okay. So then I keep going, I keep going around the circle. Now I've gone around the circle twice, so I've gone around 4 pi. I need to keep going because I need to get to 8 pi. So now we've gone around 4 pi. Let's keep going. Oh, now it's 4 pi plus pi on 3. And then keep going. 5 pi minus pi on 3. And then keep going, and I've made it all the way around 6 pi now. But I still need to go around one more time to get to 8 pi. So now I'm at 6 pi plus pi on 3 again. Oh, sorry about all the changes. And then 7 pi minus pi on 3. And then we finish going around. There's no lines down here, so I don't need to stop. And now I've gone around 8 pi. And so that's all my solutions. And so now we need to evaluate them. So we got pi on 3 for the first one. And remember, this is all equaling 4x. I don't just want to know what 4x is, I want to know what x is. So we're still not done even once we simplify these. Then pi minus pi on 3 is like 3 pi on 3 minus pi on 3, so it's 2 pi on 3. Then the next one will be 7 pi on 3. The next one, 9 pi minus pi on 3, so it's 8 pi on 3. I should say 9 pi on 3. Yep. Okay, 12 pi on 3 plus pi on 3 is 13 pi on 3. 15 pi on 3 minus pi on 3 is 14 pi on 3. And 18 pi on 3 plus pi on 3 is 19 pi on 3. Finally, 21 pi on 3 minus 1 pi on 3 is 20 pi on 3. All right. Now, to find x, what would you do to that side? We would divide by 4 to make them cancel out, so I need to divide everything on this side by 4. So pi on 3 divided by 4 is pi on 12. So we're basically just timesing the denominator by 4. Now 2 pi on 12 becomes pi on 6. Then 7 pi on 12. 8 pi on 12 becomes 2 pi on 3. 13 pi on 12. 14 pi on 12, which becomes 7 pi on 6. 19 pi on 12. And then 20 pi on 12 becomes 5 pi on 3. So there's all my answers. Now, before we move on, I want you to think about it. Does this make sense for our original question? Originally, x is between 0 to 2 pi. Let's look at our largest value of x. Is that less than or equal to 2 pi? Well, 2 pi is like 3 pi on 3, so it is less than 2 pi. So it makes sense that all of these values fit in our original domain. So that's good. It's good to think about that because sometimes you'll end up with something slightly off, in which case you can just find a equivalent angle that is within the domain. Okay, so now I'm going to go back and do B. I don't have any room, so I'm going to rub a lot of that out, and then we'll come back. Okay, cos of 2x equals negative 1 on root 2. Now, so let's think about what triangle will be helpful here. It'll be the one with pi on 4 in it. Oops, because the hypotenuse of that one is root 2. So pi on 4, 1, root 2. Okay. And I notice cos is negative, so as far as the unit circle is concerned, ASTC, my lines are going to be in the negative quadrants for cos, which is S and T, and according to our exact value triangle, my acute angle is pi on 4. Okay, now, but pi on 4 isn't one of my answers, because pi on 4 would be in this quadrant, which is not one of my, the A quadrant I should say, which is not one of my acceptable quadrants. Therefore, pi on 4 is not going to be one of my answers. Okay, so now 2x. Again, if x is between 0 and 2 pi, then 2x would be between, well, we times everything by 2. So we get 0 and 4 pi. So this time we only need to go around the unit circle twice to get to 4 pi. Because once is 2 pi, then another one will be 4 pi. So let's have a look. So for 2x, we start at 0, as the domain implies, move around, we hit one of our lines, but we need to, I don't know what that is, so we need to get to pi, then bounce back pi on 4. So my first solution is pi minus pi on 4, because we moved back pi on 4. Oops. Now let's keep going. So we're at pi here, and then we move an extra pi on 4 in the positive direction and get another solution. So my next solution is pi plus pi on 4. And then I move around, and I don't hit any more lines of angles, so I just finish the circuit for 2 pi, 2 pi all the way around, and there's my first two solutions. So let's go around again, keeping in mind I've already done 2 pi. So going around again, I hit one of my angles, so I'll go all the way down to 3 pi, because I've already gone around 2 pi, so I'm going around an extra pi, then go back pi on 4. So this time my next solution is 3 pi minus pi on 4, which we could have also gotten by just thinking of this one and adding 2 pi to it. And then my next solution, we go back to pi, and then we add another pi on 4 to get to this line here. So we're at 3 pi. And then plus pi on 4. And then we finish our circuit, get to 4 pi, and we're done. We didn't hit any more lines. Okay, so let's simplify them. Now, I've made a mistake. What have I done? I've said x equals these things, but it isn't. It's 2x. You have to put the whole angle there. So 2x. Now let's simplify it. Pi minus pi on 4 is 4 pi on 4 minus pi on 4, or in other words, 3 pi on 4. 4 pi on 4 plus pi on 4 is 5 pi on 4. Okay, 12 pi on 4 minus pi on 4 is 11 pi on 4. And 12 pi on 4 plus pi on 4 is 13 pi on 4. All right, and now we need to divide by 2, cancel, to get what x actually is. And that just means timesing all the denominators by 2. So our new denominator is 8. All right, we're finished. Now, before I move on, I'm just going to check, is this last angle within our range? So between, here it says x is 0, between 0 and 2 pi. 13 pi on 8 is less than 2 pi because 2 pi would be 16 pi on 8. So I think we're all good. All right, question 4. So now we've got angles that have additions and subtractions with it. So we're going to start it though doing our usual thing. So for tan to be 1, you may already be aware that the angle must be pi on 4. If not, you can consider both exact value triangles and realize that for the pi on 4 one, 1 root 2, the fact that these two sides are the same, it means tan of pi on 4 is 1 over 1, which is just 1. So what that tells me is that our angle, which in this case is x minus pi, equals pi on 4, at least for the acute case. Okay, but let's see if we actually want the acute case. First of all, tan is positive because it's positive 1. So let's consider the unit circle. A, S, T, C. When is tan positive? It'll be there and there. So we do in fact want the acute version, and we want this one here too. Now, just a reminder, I'm always putting in the angle between the lines that I draw and the horizontal, because they're always measured from the horizontal with trig equations, and that's why I draw it like that. Okay, so let's move around. So we want to go between 0 and 2 pi. Now do we have to adjust our domain for that x minus pi question? Now, basically, if x is between 0 and 2 pi, then if I minus pi from the middle, then I need to minus pi from everything else. Once you do that, you get negative pi, because 0 minus pi is negative pi, is less than or equal to x minus pi is less than or equal to pi, because 2 pi minus pi. So we can think of it like that. So what that means is what we can do is start at negative pi, or go to negative pi and go to pi. So in fact, in this question, we need to, from 0, we need to go to negative pi, which we get there, but we need to go to negative pi and then move back pi on 4 to get to our line. Okay, so that might be a bit confusing. Let me explain. I'm just going to run this out. Okay. So we've moved back all the way to negative pi according to this line here. So let's just write down negative pi. But then we've moved in the positive direction, pi on 4, so we actually want to add pi on 4. Okay, so that's our first solution, and in a minute I might show you another way to do it. Okay, now, and according to the rest of our domain, we want to go up to pi as well. So from 0, we go in the positive direction. Oh, that's just pi on 4. And then go the rest of the way to pi. We didn't hit another line, so that's all our answers. So let's just simplify this. So I get x minus pi equals negative pi plus pi on 4 is negative 4 pi on 4 plus pi on 4, which is negative 3 pi on 4, and our other angle is just pi on 4. But remember, I've got this x minus pi here. So what do I want to do to get x by itself? I need to add pi, so they cancel out. But that means I need to add pi here and add pi there. So I end up getting x equals, okay, negative 3 pi on 4 plus pi is just pi on 4. Okay, pi plus pi on 4 is 5 pi on 4. Okay, and that's the answer. If that sort of changing the domain and going from there confuses you too much, there is another way we could do it. Okay, I'm just going to rub this out. And show you. Okay, so we still need our unit circle. We still need to mark our lines where tan x is positive. It's pi on 4. All right, now, let's not change our domain. And just go, okay, so x minus pi equals, all right, so we're going to go from 0 to 2 pi. That's pi on 4. Oops. And go around, that's pi plus pi on 4. So we get x minus pi equals pi on 4. And then that would be 5 pi on 4. But then again, we need to add pi to both sides to cancel that pi out. And we get x equals 5 pi on 4 and 9 pi on 4. But that's a problem. Why is it a problem? Because our domain said we have to be between 0 and 2 pi, and 9 pi on 4 is beyond 2 pi, because 2 pi would be 8 pi on 4. So what we can do is we take a moment, look at our unit circle. Where is 9 pi on 4? Where is 9 pi on 4 on our unit circle? Well, 8 pi on 4 is like 2 pi, so that's like 8 pi on 4. So 9 pi on 4 would be an extra pi on 4, so it would be this angle here. So what's an equivalent angle within the domain of 0 to 2 pi that sits in the same position as 9 pi on 4? Well, that would just be the original pi on 4. So now we can replace the 9 pi on 4 with just pi on 4 because it's the equivalent angle that's in the appropriate domain. It's equivalent because it sits in the same position on the unit circle. And because we know tan and all of these are periodic and they repeat, that's why we can replace it with a smaller angle. So then we end up getting the same answer as in the first method, but just using a different method, so not shifting the domain and instead just considering our final answers. So you do whichever technique makes more sense to you. In the next one, we're probably going to do the second technique, because shifting a domain of something like pi on 3 would be really hard to work with on the unit circle because our quadrants are all in terms of pi on 2. So it's a bit too hard to shift a domain. We're going to do this second method. Okay, so let's have a go at the next one. All right, so what are some things you notice when you look at this next equation for b? I notice that sine equals a negative value, negative 1/2. So on our unit circle, we're going to be in the negative quadrants for sine, so we're going to be here and here. I notice a half, 1 on 2, so that must be to do with the exact value triangle, not the pi on 4 one. Sorry, it looks terrible, doesn't it? Pi on 6, pi on 3, 1 root 3, 2. So for sine to be 1 on 2, the acute angle must be pi on 6. Okay, so this angle here on the unit circle is pi on 6. This angle here on the unit circle is pi on 6. All right, so we're ready to go. So x plus pi on 3, we grab that whole angle in the equation, must equal, okay, we're going from 0 to 2 pi. So I'm going to move around and around and around and around. Oh, pi. I've hit pi. And then I'm going to do plus an extra pi on 6. So my first answer is pi plus pi on 6. And then my next answer, I'm going to go, okay, I've hit the line here, but I don't know what that is, so I'm going to go all the way to 2 pi and then bounce back. So because I'm moving backwards, I'm going to minus 2 pi. So I'm doing 2 pi minus pi on 6. So we get x plus pi on 3 equals pi plus pi on 6, that's 7 pi on 6. And then 12 pi on 6 minus pi on 6 is 11 pi on 6. Okay, but now I need to get x on its own, so I'm going to minus this pi on 3, so they cancel out. And I'm going to minus pi on 3 on this side too. So I get x equals, okay, 7 pi on 6 minus pi on 3 would be minus 2 pi on 6, so it's 5 pi on 6. And then 11 pi on 6 minus pi on 3, so 11 pi minus 2 pi is 9 pi on 6. Or in other words, 5 pi on 6 and 3 pi on 2. Now take a minute. Are both of those answers in our original domain of 0 to 2 pi? Yes, they are. Both of those are less than 2 pi. So you don't need to make any adjustments like we did in the previous question. Okay, so we can stop there. That's all good. All right, so now for question 5. Solve all of that. Okay, a lot going on here. Basically, up until now, we've always solved equations where it's sine of something equals something, a number. Here, I've got something in front of sine. I've got a minus 1 here. I've got to move them and make sine of the angle the subject. So first, I'm going to plus 1 to both sides. So I get root 2 sine of x plus pi on 4 equals 1, because they cancel out. And then I'm going to divide by root 2 of x plus pi on 4 equals 1 on root 2. And that reminds me of the exact value triangle with pi on 4. So the acute angle is pi on 4. If we do the unit circle, and we've also got sine. Now we know sine is a positive number, so we want to be in the A and S quadrants. Here and here, and pi on 4 is here. And now, again, we're between 0 and 2 pi. So we're going to go around from 0. That's pi on 4. So we've got x plus pi on 4 equals our first angle, pi on 4. And then keep going around. Okay, I hit my line, but I don't know what that is, so I'm going to go to pi minus pi on 4. Okay, and then if I keep going around, I don't hit any more lines, so that's all my solutions. And so I get x plus pi on 4 equals pi on 4. And pi minus pi on 4 is 3 pi on 4. But now I need to minus pi on 4 to both sides because they need to cancel out. And finally, I'm going to write it over here. I get x equals pi on 4 minus pi on 4 is 0. 3 pi on 4 minus pi on 4 is 2 pi on 4, or in other words, just pi on 2. Oops, pi on 2. And that's it. And do both of those answers lie within this? Yes, they do. The domain? Yep. So it's all good. All right, next question. Solve sine x equals root 3 cos x for x is between negative pi to pi. All right. So you see sine and cos in it. What can we do? We can use the identity that tan x equals sine x over cos x and use it by dividing both sides by cos x. The good news is we're not actually losing a solution by dividing by cos x, because I know a lot of times with equations, if we divide by a function of x, you lose solutions. But you've got to think of it, because this side here becomes tan x, all of that is within tan x. So we haven't lost anything, we're just rewriting it. These cancel out and we get root 3 over here. Okay, so which triangle has a root 3 in it? Hopefully you know it's the pi on 6, pi on 3 one. So we get pi on 6 up here, pi on 3 down here. 1 root 3, and 1 root 3, 2. And I do strongly recommend drawing these triangles for every question, and you're going to get better at remembering them. Okay, so tan of what is just root 3. Remember, tan is opposite over adjacent. So opposite root 3 is pi on 3. So opposite is root 3, adjacent is 1, root 3 on 1 is root 3. So our acute version of the angle is pi on 3. So now let's draw the unit circle. All right, so here in our new version of the equation, tan is positive. So that's in this quadrant and this quadrant, and our acute angle is pi on 3. Our acute angle is pi on 3. Okay, so if we move around, now we're going from negative, so we're going from negative pi to pi. So from 0, we go, let's do the negative pi bit first. So we go negative pi. I've hit my line, but I don't know what that is, so I'm going to keep going. To negative pi, we've moved in the negative pi direction, but then I'm going to go in the positive direction, pi on 3, so I'm adding pi on 3. So x equals negative pi plus pi on 3. And then for my other solution, which is in the pi up to pi, we're going to start again at 0 and go towards pi. We hit our line and we know that that is pi on 3. And then I'll go the rest of the way to pi, but I didn't hit any more lines. So that's it. And then I'm just going to simplify that. X equals, okay, negative pi plus pi on 3, that's negative 2 pi on 3. And pi on 3. Now, are they both in our domain? Negative 2 pi on 3 is smaller than is bigger than negative pi, because that would be negative 3 pi on 3, so that's fine. And pi on 3 is smaller than pi, so they're both in our domain, so that's it. We're finished.